Hi, this is Jntu Sultana, working as an associate professor in the Chedroad Engineering College, Chedroad. Today, I want to discuss about the semiconducting devices. In this, the PN junction. The semiconducting devices, which has a unique electrical property, hence they are used in the device to perform specific functions. Example, diodes and transistors, which are replaced the old vacuum tubes. In that, the P junction diode, which is used as a rectifier, and the junction transistors. So these two are the semiconducting devices. Coming to the first one, that is a PN junction, which is used as a rectifier. The device, the PN junction, it is a device in which the electrons only flow in one direction. Electrons only flow in one direction across it, and it acts as a rectifier. The function of the rectifier is it transforms an alternate current, that is a AC current, into the DC current, that is a DC. In its basic form, a semiconductor diode is formed from a piece of silicon by making one end CM. If you take a piece of silicon, by making one end as a P-type and other end as a N-type. This means that both the ends have different characteristics. One end has an excess electron, whereas other end has an excess of holes. Where the two areas meet the electron, these two areas, if they meet the electron, fill the holes, and there are no free holes or free electrons. This means that there are no available charge carriers in this region. That means this area is depleted of charge carriers. This area is depleted of charge carriers, and it is known as depletion layer. So when a single crystal of silicon or germanium, if it is doped with the indium at one end, I already told that it is a crystal of a silicon or germanium by making one end as a P-type and other end as a N-type. How we are making the one end as a P-type and other end as an N-type? By doping with indium at one end and arsenic at the other end. The part which is doped with the indium at one end, it is considered as a P-type of semiconductors. And the part of the silicon crystal which are doped with the arsenic, that part is considered as an N-type of semiconductors with a middle boundary region where the two sides meet. That boundary region or that junction is known as PN junction. Group 3 elements like boron, aluminium, gallium, or indium are group 2 elements like phosphorus. Group 5 elements like phosphorus, arsenic, are mostly used because of a low melting point, which is useful for high temperature diffusion of appropriate dopant elements. And this PN junction, it acts as a rectifier. The current from the outside source is allowed to flow through the rectifier only in one direction. And this is useful because it helps to convert. I told that I already discussed this point that this rectifier it is helps in converting the AC into DC. And the function of the PN junction as a rectifier is discussed below. That is, the transistor with two zones, one is a P type and other is an N type. See here. One is a P type and other is N type. If the positive terminal of a battery, see for a battery, this long line represents the positive terminal and this short line, it represents the negative terminal of a battery. If the positive terminal of a battery is connected to the P type of semiconductor and negative terminal of a battery is connected to the N type of semiconductor, holes are attracted positive. It contains the holes and it bears the positive charge. This positive charge it is attracted towards the negative voltage, and whatever the electrons which bears the negative charge, these are attracted towards the positive voltage. In that way, the holes are attracted towards the negative voltage and the electrons are moved towards the positive voltage. That means the holes and the electrons are moving in the opposite direction. They carry the opposite charges, and as a result, they represent a current flow in the same direction. They represent the current flow in the same direction. That means conduction of electricity takes place. Conduction of electrons takes place. If the positive terminal of a battery it is attached to the P type of semiconductor and negative terminal of a battery is connected to the negative N type of semiconductor. Whereas, coming to this one, I forgot to tell, this type of phenomenon and this type of mechanism is known as forward bias because the holes are moving in the forward direction and electrons are moving in the forward direction. Because the N type of semiconductor, the negative terminal of the battery is connected to N type of semiconductor and the electrons are moving, negative charge is moving in this direction and electrons are also moving in this direction. Here the holes are also moving in this direction. That means they are moving forward. That's why this phenomenon is known as a forward bias. Whereas, if the negative terminal of a battery is connected to the P type of semiconductor and positive terminal of a battery is connected to the N type of semiconductor, here the negative voltage is here only. That means the holes are attracted towards this direction. Current is flowing in this direction and the holes are attracted towards this direction. That means holes are moving reverse in the opposite direction to that of the current. And in the same way, The electrons are attracted towards the positive voltage. The positive voltage is here. So the electrons are moving in this direction. That means if the voltage is applied to the semiconductor diode, no current flows. The reason for this is that the holes are attracted towards the negative voltage or negative potential, and the electrons are attracted towards the positive potential. Both are moving away from the junction. So this is a junction, and both are moving away from the junction. The width of the depletion layer, I already told you that this region is known as a depletion layer. The width of the depletion layer increases. As a result, no current flows. And this phenomenon is known as reverse bias. This phenomenon is known as reverse bias. That in this way, the PN junction works as a rectifier. See here, a transistor with two zones, one P-type and other is an N-type, with a PN junction in between is known as a diode. If the P-type of semiconductor region is connected to the positive terminal of the battery and N-type region is connected to the negative terminal of the same battery, from N-type region, the electrons will migrate towards the PN junction, whereas the holes will migrate towards the PN junction. At the PN junction diode, the migrating electrons from the N-type region moves into the vacant hole in the valence band of the P-type of the region. Because the electrons are moving in this direction, that is towards the depletion layer or depletion region, this migration of electrons and the holes can continue and the flow and the current flow as long as the external voltage than a battery is supplied. So this phenomenon is known as a form bias. When the connection is reversed, that means N-type of N negative terminal of the battery, if it is attached to the P-type of lesion or P-type of semiconductor, and the negative, the positive terminal of the battery is connected to the N-type of the region, then the positive holes moves away from the PN junction in the P-type region and electrons migrates away from the PN junction in the N-type region. The current does not flow at this region as there are no holes or no electrons. So this is about the PN junction. Coming to the second type, which is known as the junction transistor. Junction transistor means a bipolar junction transistor is a three-dimensional semiconductor device consisting of two PN junction, which is able to amplify or magnify a signal. It is a current controlled device. The three terminals of a bipolar junction, three terminals are there. The three terminals of a bipolar junction transistor are the base, emitter, and collector. The signal of the small amplitude, if applied to the base, is available in the amplified form at the collector of the transistor. And there are two types of bipolar junction transistors will be formed. They are NPN, PNP, NPN and PNP. That means In that, first one is the PNP. We will learn about this one. In the PNP junction transistor, this PNP junction transistor is formed when N-type is sandwiched between the two P-type regions. That means the base is sandwiched between the emitter and the collector. The emitter base junction acts as a forward bias, and the base collector junction, which is considered as a junction 2, it is a reverse bias. That means emitter base junction is considered as a junction 1, and NP, that is a base collector junction, it is considered as a junction 2. The forward bias in the emitter base junction, it causes the holes to move towards the base. Because in the emitter holes are there, which moves. I told that they act as a forward bias. That means the holes are moving in this direction, moves forward. This and constitutes the emitter current. I.e., as these holes flow towards the N-type base, they try to recombine with the electrons. Because the electrons are present in this N-type, they try to recombine with the electrons. As the base is lightly doped, because it is present in the middle, it is sandwiched between the two P-type regions, it is lightly doped. As it is a lightly doped, only few holes recombine with the electrons within the base. These recombined holes constitute a small base current. The remainder holes crosses the base and constitute the collector current. A small increase in the output voltage within the emitter base circuit provide a large increase in the voltage across the base collector junction. So this is about the PNP junction transistor. Whereas coming to the NPN junction transistor, it is formed when the P-type is sandwiched between the two N-type regions. In this, the emitter is a N-type, base is a P-type region, and collector is again N-type region. That means the emitter base junction is a forward bias, whereas the base collector junction, which is considered as a junction 2, it is a reverse bias. The forward bias is applied to the emitter base and reverse bias is applied to the collector base junction. The forward bias in the emitter base junction causes the electrons to move towards the base. In the previous one, the holes are moving towards the electron. Here in the NPN junction, the electrons are moved towards the base. And it constitutes the emitter current. As this electrons flows towards the P-type base, there it recombines with the holes which are present in the base. And as it is, as the base is lightly doped, only a few electrons combine with the holes within the base. These recombined electrons constitute a small base current. The remainder electron, because only few holes are available for the recombination, as it is lightly doped, the remaining electrons, whatever will be left over, it crosses the base and constitute the collector current. So in this way, the junction transistor works. The whole explanation is here. Coming to the applications of the transistor, transistors are most widely used as amplifier, and it is used as an oscillator in the radio, TVs, televisions, computers, and hi-fi circuits. Phototransistors, solar cells, detectors for ionizing the radiations, thermistors, and tunnel diodes. So these are the applications of the junction transistor or semiconducting devices. Thank you.